Hey guys, how's it going? Today I want to talk about section 4.3. It's about functions. Some of it sounds a little bit more complicated than it is, but give it a try. It shouldn't be too bad. So basically, with writing functions, there's a couple different ways to do it. But the first thing you want you to do is sometimes you have a set of data, and you have to come up with a rule that you can that will represent that data. Well, the first thing I would want you to do is basically list some of the possible examples. So basically, like, how does a 1 become a -3? Just look at that first example. Don't worry about the rest of the numbers yet. Just look at that first one right away. How does a 1 become a -3? Well, there's two different ways that a 1 could become a -3. It could be, that you are multiplying by a -3, right? So one rule could be that we're going to multiply by -3, and that would work. Well, what's another way that a 1 could become a -3? Well, you could also subtract 4, right? So I don't know if it's going to be a multiply by -3 yet, or if it's going to be a -4, right? But then we're going to look at the second example. And the next thing we want you to do is we want to test those relationships and see if they work. If I take that where I'm multiplying by -3, if I plug in a 2, does it give me that -2, right? Well, my first guess was to multiply. If I do that here, well, that's actually -6. So I know it can't be this relationship, right? So that's out. That did not work, right? If I plug in a -2, it had to give me a -2. Well, now let's try the -4 idea, right? And see if that works. Well, if I plug in a 2, 2 minus 4, -2, that works. If I plug in a 3, -4, sure enough, that's -1. If I plug in a 4, and I go -4, sure enough, it gives me 0. So yes, it was the -4 idea that works. So the last thing to do is, once we figure out which example worked, which relationship worked, well, all we have to do is we got to write the relationship. Basically, the y will equal, if we ever take the x value, right? And all we did was -4. Okay, so there's our relationship. And you can test it. You plug in the 1. The 1 is the x value. We minus the 4, and we got the y. Okay? Now, there's some technical things we have to talk about with this as well, and those are what those variables are called. We're going to have what we call an independent variable. The independent variable is always going to be the input. So in this case, the input is the x value, right? We're putting the numbers into the x, right? We plugged in a 1, we plugged in a 2, we plugged in a 3, right? This is where we plug those numbers in. That's called the independent variable. The dependent variable is the output, okay? Another way to think about this is, in any situation, the dependent variable is going to depend on the independent variable, okay? So a couple real-life examples here. In the winter, I burn more firewood when the temperature drops. Well, which one is going to be the dependent variable and which one is going to be the dependent variable? The temperature, okay, well, that's independent, okay? That's not something that we control. That's going to be the independent variable. The amount of firewood, okay, how much firewood we burn, that is going to depend on the temperature, right? How much firewood we go through depends on what the temperature is. This winter, if we have a really mild winter where we have some warm temperature, we're not going to burn as much firewood, right? We're not going to go through as much. But if we have a really cold temperature, okay, then we would burn more firewood. the amount of firewood we burn depends on what the temperature is. Okay. Another example, the cost of shipping depends on the weight. Well, we have two variables here. We have the shipping cost and we have the weight. Well, the shipping cost depends on the weight. So that means the weight is the independent variable. We can't really control that. The shipping cost, though, will depend on whatever the weight is. So that means these would become the inputs. These would become the outputs. Okay? All right. So we can try a few more examples here. Now, we also have a real formal function notation. Okay? Once we decide what the dependent variable is, the dependent variable is going to be a function of the independent variable. Okay. What we need to understand is the y is going to equal f of x. This does not mean f times x. This is what we call function notation. The way you read this is actually y is equal to f of x. F is a function of x. Okay. So this is what we call function notation. These two equations actually are the exact same thing. This just means y is equal to 2x plus 1. The way you read this, f of x is equal to 2x plus 1. These two things mean the exact same thing. If you ever see this notation, if you want to, you can write it in this notation. It's just another way to write it. And likewise, if you see an equation written like this, if you want to put it in function notation, these two things mean the exact same thing. So if you ever see this, if you want to, you can just replace it with a y. Okay? And we'll talk more about these examples in just a second. Okay? Now, let's say we have to write an equation for a situation. Okay? Well, the first thing we have to figure out is what are the dependent and the independent variables. So we have a basic situation. Lawyer fee is $200 per hour for her services. So what is the dependent variable and what is the independent variable? Well, the dependent variable is going to be the fee, right? How much it costs for the lawyer depends on how many hours, right? So how many hours is going to be the independent. The fee is going to end up being the dependent. Okay, so let's let f be the dependent variable. Okay, we'll use f here, and we'll use h to represent the hours. Okay, so basically what we can do is we can write an equation of something like f of h. Okay. And basically what we're going to do is h is going to become the independent variable. So that's the input. We're going to put h in here. Now, what would we do with this? $200 per hour. We would just multiply the h, the number of hours, by 200, and that will give us our fee. So we can actually now just plug in and find like f of 1. Well, that would mean all we did was we talk to the hour for 1 hour. So we would just plug in a 1, 200 times 1 would be $200. So the fee would be $200 for 1 hour of service. If we talk to the lawyer for 3 hours, we would say f of 3, and all we would do is plug in a 3 in for the h, and then we just multiply. 200 times 3, 600. So f of 3 means we would talk to the lawyer for 3 hours. We'd plug in a 3. The cost would be $600. Make sense? And basically, that's how all of these are going to work. If f of x is equal to 5x, we have to find f of x when x is 6. Well, basically, all we have to do is find f of 6. Well, f of 6 would be, we replace the x with a 6. We're going to replace this x with a 6. The answer would be 30. Find it when x is 7.5 means we're going to find f of 7.5. Well, that means we have to do 5 times 7.5. Well, that's pretty easy to do. Grab a calculator. 5 times 7.5, 37.5. So f of 7.5 would equal 37.5. Okay? And that's really all we're doing there. When it says find when x is 6, all it means is find it when f of x is, so it'd be f of 6. And we just plug in a 6. Similarly, if you have a little bit more of a equation, 2x minus 3, find f of x when x is negative 2. Well, that means what we're trying to find is f of negative 2. And all we do is we rewrite that 2x minus 3, but we're going to replace the x with the negative 2. 2 times negative 2 is negative 4, minus 3 would be negative 7. So that means f of negative 2 is equal to negative 7. Find it when x is 5 means we're finding f of 5. Well, again, all we do is we rewrite that 2x minus 3, but we're going to replace the x with a 5. 2 times 5 is 10. 10 minus 3, 7. So f of 5 is equal to 7. We're not doing anything different than what we used to with this notation. Before, we would plot points and we would, do something and we'd want to find, like, plug in a 2 or plug in a 4. When you plug in a 2, 2 times 2 is 4 plus 1 is 5, right? You plug in a 2, you get out a 5. You plug in a 4, 2 times 4 is 8. 8 plus 1 is 9, right? In this notation, all we're doing is we're saying, what is f of 2? Well, f of 2 is 2 times 2 plus 1. So f of 2 is 5. And then we're saying, what is f of 4, right? F of 4, you'd say 2 times 4 plus 1, which would be 8 plus 1. So f of 4 is equal to 9. We're doing the same thing we did over there. It's just kind of a different notation, okay? Different way of kind of doing the same thing. And let's try one more example here. Let's say we had h of c. This doesn't have to be an f. This doesn't have to be an x. It can be any letter of the alphabet, right? This just means h of c. Oops, that should be a c. Okay. If h of c is equal to the function 1/4 c minus 1, find h of c when c is equal to negative 12. Well, that just means we're trying to find h of negative 12. And again, all we do is we rewrite the equation, the expression, 1/4 c minus 1, 1/4 c minus 1, but we're going to replace the c with a negative 12. Remember, multiplying by 1/4 is the same as dividing by 4, or you can multiply by 1, divide by 4. So we're going to get negative 3 minus 1, which would be negative 4. So that means h of negative 12 is equal to negative 4. And then if I want to do the same thing, find it when c is equal to 24, well, we're basically finding h of 24. And again, we just rewrite the equation, but we replace the c with a 24. 24 times 1 is 24. 24 divided by 4 is 6. Minus 1 is 5. So h of 24 is equal to 5. Okay? Now, it's important to note, we've kind of already talked about a little bit. If our independent variables are our inputs are our domain. So our domain is always going to be the numbers we put on the inside of the function. They're our independent variables. Our range is our outputs, which means it's our dependent variables. Okay? So, in a real life situation kind of thing, what we need to be able to do is look at being able to write an expression and be able to find the domain and range. So let's take this example here. Bill has sold $20 worth of tickets. He's already got $20 to the game. He has 4 tickets left to sell at $2.50 per ticket. Write a function rule to describe how much money Bill can collect from selling tickets. Well, Bill, so let's use a B of T, right? Number of tickets, right? Bill's going to have how many tickets? That's the tickets. The number of tickets is the input. That's going to be our independent variable, right? How much money he has depends on how many tickets he's going to sell. Well, he already has $20, right? Plus $2.50 per ticket, right? So he has $20 already, and he's going to add $2.50 per ticket he sells. So this is our function rule. Okay. Now, what's the input? Well, what are the variables that he could plug in? Well, how many tickets could he sell? His domain is going to equal, he could sell 0 tickets, more tickets. He could sell 1 more ticket. He could sell 2 more tickets. He could sell 3 more tickets, or he could sell 4 more tickets. That's it. He only has 4 more tickets to sell. So this is our domain. These are the only numbers that he could plug into this particular example, because he could only sell 0 tickets through 4 tickets and anywhere in between. He can't sell negative tickets, right? The range is going to be what happens in each of these situations. What happens when he sells 0 tickets? What happens when you get B of 0? Well, B of 0 is going to be 20 plus 2.5 times 0. 2.5 times 0 is 0. 0 plus 20 is 20. So he could end up with $20. He has $20. If he sells no more tickets, he still ends up with $20. If we plug in a 1, B of 1, well, now we're doing 20 plus 2.5 times 1. Well, 2.5 times 1 is 250. 250 plus 20 is 2250. So if you plug in a 1, you get 250. If he sells 2 tickets, right, if you add another 250, he'd have $25. If he sells 3 tickets, if you add another 250, it'd be $27.50, right? And then if he's 1 more ticket, if he sells all 4 tickets, you plug in another 250, and it'd be up to $30, right? So there is our range. Okay? So basically, what we need to be able to do is come up with an expression to represent the equation. He had $20. He was selling $2.50 per ticket. Our domain was how many tickets could he sell. I mean, he can't sell half a ticket, so we don't have to worry about decimals. And he couldn't go negative, and he only had 4 to sell, so this was the only situations that could come up. And then the range of is the numbers that he could end up with. He could end up with $20. He could end up with $22.50, $25, $27.50, or $30. These are the only numbers that could pop out of that situation. Okay? So, again, that's all this stuff is. Try a few examples and let me know how it goes. Talk to you guys later.